So you see this title today says Factoring with Conjugates. You have no idea what a conjugate is in math. You may know it from French or Spanish where you conjugate a verb, but it's a little different in math. And we're not going to hit on it right away. We're going to set up a pattern first. If we were to multiply here, hopefully by now we know we're double distributing. X has to get passed out. And then the 3 has to get passed out. Okay, I'm going to leave that for a second. I know I can combine these middle terms right here, but I want you to pick up a pattern. Distribute an X to everybody. Distribute a 3 to everybody. Did you see something here? Did you notice the middle terms? Well, in one case, the middle terms canceled out. A -3 and a +3. Cancel those terms out, so I'm simply left with x squared minus 9. But in the second one, the middle terms didn't cancel out. In fact, they doubled. And I was left with x squared plus 6x plus 9. Well, let me look back and see why. The one that they canceled out, one was positive and one was negative. The one where they didn't cancel out, they were both +3. Let's keep that in mind as we go along, see what else we got here to multiply. All right, so we come down to this next one, and we see again with this one that we have a plus and a minus. All right, let's go back and look at this plus-minus pattern up here. Is that going to happen again? Distribute the n squared minus 5n. Distribute the plus 5. Hey, look. Once again, those middles are going to cancel out. So have we figured out an easy way to multiply when one is a positive and one is a negative? Well, yeah, that's what a conjugate is. A conjugate means to change the sign of the second term of a binomial. So when I look at the next one, they are not conjugates of each other. They're the same. So the middle terms are not going to cancel out. Distribute an n. Distribute a 5. And we see the middle terms don't cancel out. In fact, they double. So now when we see this next one, can we recognize the pattern right away? We see that they are conjugates of each other. They're binomials, and we changed the sign of the second term. In other words, it was a -8 to begin with, and the second time I wrote it as a +8. So I know that the pattern is going to be n squared minus 8n plus 8n minus 64. And if the middles cancel out, well, we can just jump right to the final answer. This last one, again, they're not conjugates because they're both negatives, but we saw what happened back here when we had both positives. So maybe it's the same thing. The middle term is still going to be doubled. It's just doubled as a negative. You can still get all these answers by doing double distribution. But as in math, if we can find a pattern, it makes things go a lot faster. Now we're going to go backwards. We're going to undistribute. Now I'm giving you the answer. Can you tell me what two binomials were multiplied together to get this? X squared minus 100. If I come back here and look, which one does that look like? It looks like this one, and this one. All of those came when I multiplied two conjugates together. So this is x minus 10, and then its conjugate is x plus 10. So remember, I told you we were going to get into finding two binomials that multiply together to get us something. This is also called a difference of two perfect squares. And can you see why? There's a difference sign. And difference means to subtract, and I'm subtracting a perfect square and a perfect square. So this is a very common type of factoring, which we're going to require you to know, and you're going to use it from now right through to calculus. So that when you see a difference of two perfect squares, b squared minus 49, awesome. I know I obtained that answer by multiplying together the conjugates of each term's perfect square root. So the square root of b squared is b, the square root of 49 is 7. One's a minus, one's a plus. This is a difference of two perfect squares. Remember, the square root of 1 is 1. One's a plus, one's a minus. There's that conjugate coming into play. What is the square root of 81 squared? 9y. And there we have it. Now with this one, 4x squared minus 64, it is a difference of two perfect squares, but this is kind of a little foreshadowing of where we're going to go. Remember, the other day, we did common factoring first. So if I pull out a 4, I get x squared minus 16. That's still a difference of two perfect squares. And then that factors down to x minus 4 times its conjugate, x plus 4. This is where we're heading. This is called a complete factorization. You have a lot of types of factoring to learn. Greatest common factor was what we did yesterday. Today you're learning a difference of two perfect squares. Tomorrow you'll be learning trinomial factoring and then factor by grouping. And these are all very important, and you'll see why in Chapter 8, but little by little. Now this one right here, this is not a difference of two perfect squares, but it is something we saw on the first page. We did see that when we multiplied two binomials together that were exactly the same, we got a middle term. So here, we look at this and we know, well, it's two binomials multiplied together. A times A gets me A squared. 5 times 5 would get me 25. And then if they were both plus, I realize I get that middle term of 10. And once again, this is not really today's topic. This is going to be tomorrow's. How to always do a trinomial, get it? 1, 2, 3 terms. But just again, a little foreshadowing. All right, so for summary, we have two types of factoring that we are going to be practicing tonight. Greatest common factor, and then what you learned today, see if it is a difference of two perfect squares, and they factor into their conjugates.